All right, good morning, everyone. I hope you guys are doing well, and we're going to start today's lesson on 4.6, which is entitled Logarithmic and Exponential Equations. This is not necessarily the easiest section. It is combining kind of what we've been doing all together at once, and this would be the 8th of March. So pretty much all I have is a series of examples. I have, I have 6 examples, and I'm just going to kind of walk through them. And you can access this via YouTube on my channel, and I'll give Mr. Paulson or whoever's subbing access, and however you, so that way you can get access to this. So here we go. We're going to start by looking at how to solve, so solving a logarithmic equation. All right, here we go. A logarithmic equation. Title for these type of examples. All right, I'll start with example number 1. So we have 3 times the log base 2 of x, and that equals negative log base 2 of 27. All right, well, here we go. Let's use some of the properties that we know. We know that this number out in front really can be put back as an exponent, and I'm going to do that with both of these. So instead of 3 times log base 2 of x, I now have log base 2 of x cubed, and that equals log base 2 of 27 to the negative 1 power. Now, if the bases are the same, if we know log base 2 of x cubed is equal to log base 2 of 27 to the negative 1 power, then we know that x cubed has to equal 27 to the negative 1 power. That's using one of our properties. But you can also think of it as this way. It's saying 2 to the what power gives you x cubed, and this is saying 2 to the what power gives you this. Therefore, they have to be equal to each other. So I know that 27 to the first power is really 1 over 27. We then get rid of the cube by cube rooting both sides. Now, when you cube root, it's not plus or minus because of the fact that it's a cube root, right? A negative times a negative times a negative is a negative. So it is its own sign. So we have x equals, you can split up the cube root, and you ultimately have cube root of 1 is 1, and the cube root of 27 is indeed 3. So x equals 1/3. Not too bad, right? All right, here's example number 2. Let's get a little bit harder. I'm going to throw in the natural log because you guys seem to think that the natural log is a little bit scary. So I have the natural log of x plus 1 minus the natural log of x, and that equals 2. Well, let's use our properties. If we know that they have the same base, natural log is log base e, and it's a subtraction problem, this is really the same as saying the natural log of x plus 1 over x. And I'm going to put that in parentheses, and that still equals 2. Then we can put this back into exponential form. This is saying log base e of this equals 2, which is the same as saying e to the second power equals x plus 1 over x, right? Because this is log base e, we can turn it into exponential power. And then I'm going to try to clean this up. I'm going to actually multiply both sides by x. So I end up with e squared x equals x plus 1. I want to try to isolate x. My goal is to solve for x. So I'm going to move this x to the other side. I want all my x's on one side. So I have e squared x minus x equals positive 1. I'm now going to factor out that x. I have e squared minus 1 equals 1. Keep in mind, e is not a variable. E is a number. It's like pi, right? E is a number. So don't treat it like a variable. Treat it like a number. And now to get x all by itself, I'm going to divide both sides by e squared minus 1. So my final answer is, you could either leave it as 1 over, oh my gosh, this pencil is horrible, 1 over e squared minus 1, or you can punch that into your calculator and you get approximately 0.157. Okay? All right, the book has a whole bunch of different examples like this as well. Let's jump down to dealing with solving an you can't see this anymore. I'm running out of space. Right, let me move this up, excuse me. Okay, let's look at this. Solving an exponential equation now. I hope you were able to see the bottom as I was doing this problem over here. Okay, so let's see, example number 3. If you have something like 3 to the 2x power plus 3 to the x power minus 2 equals 0, and we're asked to solve for x, what I want you to start to look at in a problem like this is, do you see that this is kind of like, if I were to say, I'm going to take a letter u, and I'm going to say that u equals 3 to the x power. Do you see I have a 3 to the x power? I have 3 to the x squared power. This is really, and if it's easier for you to see this, this is really 3x to the second power. I can remove that 2 plus 3x minus 2. If you can see this, this is really a quadratic. U squared plus u minus 2 equals 0. This is really a quadratic here. So let's just factor this quadratic, and then we'll replace what that u really equals. I'm using u because we already have an x here. I'm using u as just a random variable. So this is kind of like u times u. What times what gives you 2? Oh my gosh. And adds to a positive, so we're going to have 2 times 1. We need a positive 2, so it's going to be a positive 1, so we have a positive 2 minus, and we factored this. So u really does equal 3 to the x power. So this is 3 to the x power plus 2 times 3 to the x power minus 1, and that equals 0. That's the hardest part, is to see that this is really a quadratic in disguise in an exponential function. Then to solve for this, we set each one of these factors equal to 0. Right? You set each one of these factors equal to 0. Let me lift this up so you can see it a little bit more. Right? So we have 3 to the x power equals negative 2, and then this would be 3 to the x power equals 1. Let's work with this one first. 3 to what power gives you 1? Well, we know that that's 0, right? 3 to the 0 power equals 1. And then 3 to what power gives you negative 2? 3 to what power gives you negative 2? Nothing, right? Because anything you raise this to the power 2 will always come out positive. So this is a no solution situation. Our final answer is just purely x equals 0. That's the only solution to this equation. All right, moving along quickly. I'm going to turn this over, and let's look at example number 4. We're going to keep with this type of problem. Example number 4. Okay? Example number 4, hopefully my hands have not been in the way this whole time, because it's hard for me to see what I'm actually doing. 2 to the negative x power equals 1.5. All right, we're going to solve this one. We're solving for x. That's our goal, is to solve for x here. All right. Well, you can't just, the easiest thing would be to actually put this in log expression. So say this would become log base 2 of 1.5 equals negative x. We can divide both sides by negative 1, so we have a positive x. And I'm going to put this negative out in front. This is saying the negative of log base 2 of 1.5 equals x. All right? And now, since we can't just plug this into our calculator, this is where we're going to use the change of base formula so that we can plug this into the calculator. Using the change of base formula at this point, I have negative log base 10, or just log, of 1.5 over log base 10, or just log, of 2. And that equals x. That you are going to punch into your calculator. You're going to hit log of 1.5 divided by log of 2, and then it is indeed negative, and you get that x is approximately negative 0.585. A lot of these are going to not come out very pretty. They're going to be some strange looking number. Okay, that one wasn't too scary, hopefully. All right, example number 5. We have, let's solve 2 to the x plus 1 power equals 5. I'm going to pause for just a moment.